In this video, I'm going to go over some examples relating to multiplying and dividing rational expressions. Now, before I start with the examples, let me remind you to multiply two rational expressions, P over Q times R over S. We simply multiply the numerators and divide by the product of the denominators. So that's PR over QS. That's how you multiply rational expressions. What about dividing? Let's say we would like to divide P over Q by R over S. Well, to do that, you leave the first expression intact, turn the division symbol into multiplication, and then take the reciprocal of the second expression. That'll be S over R. So we transform division into multiplication, and we already talked about multiplying rational expression. So that would be PS divided by QR. So during this video, I'm going to go over the examples that are listed on the screen. Starting with the first example, to multiply 28 minus 7z over 4 times 12 over 2z minus 8, let's factor everything as much as possible and simplify if there are any simplifications. So 28 minus 7z, we can factor out a 7. That would leave us with 4 minus z divided by 4 times 12 over 2z minus 8. We can factor out a 2, and that leaves us with a z minus 4. Now, how do we multiply two rational expressions? You multiply the numerators and divide by the product of the denominators. So we have 7 times 4 minus z times 12 divided by 4 times 2 times z minus 4. Canceling out common terms. Now notice 4 minus z and z minus 4, you can cancel them out, but you have to account for a negative 1, because 4 minus z over z minus 4, that's simply a negative 1. So in our answer, we're just going to have a negative. Now, $12 divided by 4, that leaves us with a 3. And 7 times 3 is 21 divided by 2, so our answer is negative 21 over 2. Next, let's multiply 8r plus 16 over 24r minus 24 times 6r minus 6 over 3r plus 6. So I'm going to factor first before I multiply. 8r plus 6, factor an 8, we're left with an r plus 2, times 6r minus 1, that leaves us with 6 times r minus 1. Let's look at the denominators. 24r minus 24, that's 24 times r minus 1, times 3r plus 6, that's 3 times r plus 2. Let's cancel the common factors. R plus 2, R plus 2, R minus 1, R minus 1. Now, 6 over 24, that leaves us with a 4 in the denominator. 8 over 4, that leaves us with a 2 in the numerator. And after all is said and done, the final answer is simply 2/3. So interestingly, this complicated looking product of rational expressions is none other than 2/3. Next, let's look at a division problem. Z squared minus 3z plus 2 divided by z squared plus 4z plus 3, all of that divided by z minus 1 over z plus 1. So let's transform this problem into a multiplication problem by preserving the first expression, rational expression, z squared minus 3z plus 2 over z squared plus 4z plus 3 times the reciprocal of the second expression, that's z plus 1 over z minus 1. Next, I'm going to attempt to factor everything as much as possible. Z squared minus 3z plus 2, you can check that it's simply z minus 1 times z minus 2 times the z plus 1 from the second rational expression. Furthermore, z squared plus 4z plus 3 is factored as z plus 1 times z plus 3. You can check that times the z minus 1 from the second rational expression. Let's cancel out the common factors, z minus 1, z minus 1, z plus 1, z plus 1, and that leaves us with z minus 2 over z plus 3. Next, let's divide the expressions t squared minus 49 over 42 minus 6t by t squared plus 10t plus 21 divided by 6t plus 42. So let's transform the division into multiplication by the reciprocal. So t squared minus 49 divided by 42 minus 6t times the reciprocal of the second expression, 6t plus 42 divided by t squared plus 10t plus 21. Now let's factor everything as much as possible. T squared minus 49 is the difference of 2 squared. This is something of the form a squared minus b squared. You can factor it as a minus b times a plus b. So that'll factor as t minus 7 times t plus 7 divided by 42 minus 6t. If we factor out a 6, we're left with 7 minus t times 6t plus 42. We can factor out a 6. That'll leave us with t plus 7. And finally, t squared plus 10t plus 21. We can factor that out as t plus 3 times t plus 7. So let's write everything out. T minus 7, t plus 7 times 6, t plus 7, all divided by 6, 7 minus t times t plus 3, t plus 7. And let's cancel out the common factors. T plus 7, 6 and 6 cancel out. Now, t minus 7 and 7 minus t almost cancel out. They cancel out by resulting in a negative 1. T minus 7 over 7 minus t is negative 1. And then we have a t plus 7 divided by t plus 3. So we can write our answer, if we like, as minus t minus 7 over t plus 3. That is, if we distribute the negative to the numerator, we get minus t minus 7 over t plus 3. Finally, let's look at the expression q minus 3 to the fourth times q plus 2 divided by q squared plus 3q plus 2, all divided by q squared minus 6q plus 9 over q squared plus 4q plus 4. Let's start out by turning the problem into a multiplication problem. Q minus 3 squared, q plus 2 over q squared plus 3q plus 2 times the reciprocal of the second expression, that's q squared plus 4q plus 4 divided by q squared minus 6q plus 9. Next, let's factor everything as much as possible. Q minus 3 to the fourth is already factored. Q plus 2. Now, q squared plus 4q plus 4, if we factor that out, we'll get q plus 2 squared. So we'll have a q plus 2 times q plus 2. Q squared plus 3q plus 2, if you factor that out, that would be q plus 1 times q plus 2. And q squared minus 6q plus 9 is simply q minus 3 squared. So we'll have a q minus 3, q minus 3. Let's factor out the common terms in the numerator and the denominator. Q plus 2, q plus 2. We have a q minus 3 to the power 4 and q minus 3 squared. So that would leave us with a q minus 3 squared in the numerator. And when we write our final answer, we have q minus 3 squared. We have 2q plus 2, so that's q plus 2 squared, divided by q plus 1. At this point, nothing can be simplified, and that's the result of our division.